Okay, students, in last class I have seen a formation of images on convex lens. Now in today's class, over concave lens, we observe formation of images. So this time F1 and C1, F2 and C2. The images have been created. Let us check it. So like previous cases, here also in front of a concave lens we can place the objects at same positions. But an interesting thing is, in case of concave lens, in almost all the cases except at infinite distance, we are going to get similar kind of images and similar positions. In all cases, the nature of image will be same. But when we discuss about a position, except the infinite distance case, in remaining all cases, we are going to have a same kind of images. So let us see how it will be. For example, if the object is at infinite distance, we know when the object is at infinite distance, it is able to release only parallel beam of light. It is able to release parallel beam of light. And we already also know that the parallel beam of light takes refraction straight to focus. So these refractor rays will get converged at focus. See, when these light rays take refraction straight to focus, so the light rays are here will not combine with each other. So these are divergent light rays. When these divergent light rays stretched back at focus, they are going to get combined. So here image is formed. The image is formed here by divergent beam of light. So due to this divergent beam of light, an image is created so that it is virtual, erected, and its size is obviously diminished, smaller one. And where is the image is? Image is formed at focus. Similarly, in remaining cases, you see F1, C1, F2, C2. Anywhere and wherever you keep the object which is placed it will be, now it is able to release any kind of light rays because it is not at infinite distance. So we try to emit a parallel beam of light. This light ray takes refraction straight to focus. Optic center, this is the light ray which is incident through optic center, it goes straight without deviation. So the two light rays are again divergent beam of light. So their extension inside will meet here, and here when we draw perpendicular to the principal axis, this represents an image. See, this is formed once again by divergence, so it is virtual. Object and image are on same side of principal axis, so we can call them erected, and compared to object, image length is smaller, so it is diminished, and the place means it is between focus and optic center. is between focus and optic center. This is formation of image by concave lens. In all the cases except the infinite distance, that means beyond center of curvature, at center of curvature. Now the current question is between center of curvature and focus, even the focus between focus and optic center. At any situation when an object is kept, we are always going to form virtual, erected and diminished image, and it will be formed between focus and optic center. At infinite distance also we got the same virtual, erected and diminished image, but image position has been at focus. That's it. This is about ray diagrams. Now in today's class we are going to discuss about lens maker's formula. We discuss about lens maker's formula. The formula which is going to describe or which is useful to construct a lens, it is called lens maker's formula. So the lens maker's formula is this: 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. This formula is being called lens maker's formula. Here where f is equal to focal length, n is refractive index of two media, means relative refractive index, and R1 and R2 are radii of both curved surfaces, radii of both curved surfaces. And you must remember that sign convention rules are applicable. In this, Cartesian sign convention rules are applicable. We must need to apply this. Okay, now we see the derivation of the equation. To make the derivation of the equation, we have derived initially of this lesson a mathematical calculation to understand the relation between refractive indices and objective distance in image distance when light takes refraction on curved surface. That relation is n2 by v minus n1 by u is equal to n2 minus n1 by r. This derivation in beginning of the chapter we had. This derivation we are going to use to derive refract lens maker's formula. Okay, let us start it. So we make the diagram. So initially we consider a curved surface. It is the principal axis and its center is going to be assumed C1. Its center of curvature to be assumed C1, and the distance from curved surface to this is being R1. So remember, this curved surface before, let us take a media, and behind this curved surface it will be another media. So this media is to be Na, the second media is to be Nb. Okay, now in front of this object somewhere, whenever we keep an object, it will emit light rays. The light rays will fall on the mirror, so on the curved surface, refracting curved surface. Now here we have a normal, by assuming rarer to denser, because this is a refracting body and that's the part of a lens. So we always can observe the lens refractive index is greater than a surrounding medium. Okay, like that we have taken, just assume. So then what happened, this is having less refractive index, means it is a rarer medium and it is denser medium, and the light ray is going to bend towards normal and meets the point where it will form an image is I dash. And now the curved surface to object is an objective distance, let it be u, and this surface to image, the distance will be image distance, let this be x for our sake. We are going to consider this x. Now let us substitute these values in the previously derived equation, that is n2 by v minus n1 by u is equal to n2 minus n1 by r. In this equation, these values we are going to substitute. But before the substitution, we must check their sign convention also. See, we sign convention rules, any distance should be measured from optic center. So this, for this curved surface, this point will be optic center. From this, the light incident ray direction is this one, that means left to right. From this point, left to right measurements are positive, right to left measurements are negative. You see, only one measurement is from right to left, that is objective distance. So u is minus u, v is plus x, r is plus r1 radius of curvature. So that what are we going to substitute? By substituting these values here, yeah, we forgot n1 and n2. n1 first medium is Na, n2 n. Now substitutions. n2 place nb by v is plus x minus n1 means na by u is minus u. n2 minus n1 means nb minus na by r is plus r1. Now substitutions after that, nb by x minus of minus plus na by u equal to nb minus na by r1. Let this be equation 2. Sorry, we had only in one equation. This will be first equation. Okay, now go back to the diagram. So lens means a refracting body with both surfaces. We have here now only one curved surface. Let us take the other curved surface we are going to construct, whose center will remain this side and have C2, and let us assume the radius is R2. Let us assume the radius is R2. Okay. By doing this, what is going to happen when the second surface is taken? The image at I dash will take refraction again, because here there is change of medium. The light is traveling from NB medium. By cutting here, we are going to have atmosphere, and this side we are having a NA medium. So light is now propagating from NB to NA, and the light take refraction and produce an image I at somewhere. Let this image distance be V. Now what is going to happen? X image has been shifted to V and producing a radius of curvature R2. For these three, let us take the sign convection. You see, the light propagation is from NB to NA. That means here N1 is going to be called NB, N2 is going to be called NA. Now objective distance U will be plus X, because this will be the objective distance, and image distance V will be plus V. So both are on the right side, so we take the positive. And radius of curvature, see, radius has been formed the other side, so we take that minus R2. We are going to take that minus R2, and the same equation, by substituting we get equation 2. Here N2 by V minus N1 by U. N2, what have we taken? NA. N2 means NA by V, image distance, plus V minus N1 means NB, objective distance, plus X, N2 minus N1, that means NA minus NB by radius is minus R2. Here I will make a small modification in RHS, that is NA by V minus NB by X equal to minus in denominator taking into LHS, plus NA becomes minus, minus NB becomes plus, then it will be NB minus NA by plus R2. Now this is equation 2. How are we going to resolve this? Make equation 1 plus equation 2. Equation 1 plus equation 2. Equation 1 is what? This is equation 2. How will be the equations addition? LHS plus LHS is equal to RHS plus RHS. Here LHS is NB by X plus NA by U, plus here LHS is NA by V minus NB by X. Now RHS, NB minus NA by R1 plus NB minus NA by R2. Now here NB by X minus NB by X will get cancelled. The 2 will get cancelled. Now we have from the terms NA is common, bringing that out, 1 by U plus 1 by V. From these two terms NB minus NA is common, bringing that out, 1 by R1 plus 1 by R2. Now NA is transposition. I will write this 1 by V plus 1 by U. This one transposition, NB minus NA by NA 1 by R1 plus 1 by R2. Now verifying sign convention rules once again. So from the already we have written them. What are that? V. So what do we have? V, U, R1, R2. Let us check what are they. Here we checked. V positive, U negative, R1 positive, and R2 negative. Taking that 1 by V positive, U is negative, NB minus NA by NA. Cancelling here, we get NB by NA minus NA by NA, resolving into fractions. And here R1 is positive plus R2 is a negative. R2 is negative. Now 1 by V minus 1 by U according to lens formula, it is 1 by F. Here NB by NA will be the ratio of relative refractive index N minus NA cancels each other, leaves 1, and we have in the bracket 1 by R1 minus 1 by R2. This is lens maker's formula. Okay, stop it. This is lens maker's formula. In next class we discuss the lens formula and magnifications. Okay.